Hello everybody, welcome to this Climate Now Live here on the Euronews YouTube channel. My name is Jeremy Wilkes, science reporter at Euronews, the host of the Climate Now program, which you can see on euronews.com/climate now. And today we are here to talk about the state of our climate here in Europe, because this week we saw the publication of the Copernicus Climate Change Service's annual European State of the Climate report, and we have guests here who are going to help us to understand some of the detail in that report. We're going to be talking about extreme heat, what that means for your health, the risks that are out there. We're going to be talking about the state of our oceans. We saw record-breaking figures in 2023. We're seeing them again at the moment. What's happening and why? Also, a lot of people tell me it's been raining a lot more than average. Is that really the case? And if so, is that related to climate change in some way? And we're going to be talking about solutions as well. So there's a lot to get into. Please stay with us for the next hour. Send us your questions in the chat if you like, and let us know what you're concerned about. And let me welcome our guests. Samantha Burgess, the Deputy Director of the Copernicus Climate Change Service. Hi, Sam. Nice to see you. Where are you joining us from and how's the weather?
From Reading in the UK, and it's much cooler than the average for this time in April right now.
It's chilly where I am in France as well, in Lyon, absolutely. Let me also welcome Francesca Racioppi, the head of the WHO's European Centre for Environment and Health. Hi, Francesca, nice to see you. Where are you joining us from and how's the weather?
Well, I'm from Bonn. We are just by the river. You cannot see because you have my screen. And today the weather is cloudy and coldish.
Yeah, seems like it across Europe. And Diana Ürge-Vorsatz, professor at the Central European University and IPCC vice chair. Thanks for being with us. Where are you? How's the weather?
Hi, I'm at Lake Balaton in Hungary, and the weather is the same, very cold and very cloudy and rainy.
I have very fond memories of holidays at Lake Balaton. What a lovely place. And let's then go over to our fourth guest, Helen Findlay, who is a biological oceanographer at Plymouth Marine Laboratory. I'm assuming you're in the sunny southwest of England. Is that correct?
That is correct. Yeah, I'm in sunny Plymouth and the sun is actually shining today, although it is still pretty chilly and there's a chilly wind at the moment. So.
Yeah, absolutely. Seems the same for everybody at the moment. Rather exceptional, somewhat different, I suppose, to a lot of what we're going to be talking about. We have just seen the publication of the Copernicus European State of the Climate Report for 2023. In a sentence or two, Sam, what are the main findings from that report? What is the state of the European climate today? How can we characterize it?
So as greenhouse gases continue to increase, temperatures also continue to increase, including in the ocean, and sea levels continue to rise, glaciers and ice sheets continue to melt. For 2023, it was the warmest year on record and the joint warmest year on record for Europe. The 3 warmest years on record for Europe have all occurred since 2020.
It is a difficult picture for anybody who's very concerned about our climate, which should be everybody watching this and everybody in Europe, because it seems like every month I'm saying it was the warmest, it was the hottest, here's a new extreme. Francesca, from 2023, what was the kind of standout moment for you in terms of climate change? Was there a moment that really marked you?
Well, I would say there have been 3 moments that will stand with me for the foreseeable future. The first was when in July, for the first time in our history as a World Health Organization, we decided to declare the ongoing heat wave as a health emergency. And this has a very specific, meaning for the WHO because it activates our emergency response. And that was done because for the first time, we really felt that we needed to really ring the highest possible alarm. And to give you an idea, we were treating this along with emergency like COVID, just to give you an example, or the ongoing wars. So it was unprecedented, terrible moment. And then 2 moments where I would say more positive ones from a political point of view, when in June the member states came together at the ministerial conference in Hungary, in Budapest, and they decided to take much bolder action on the links between climate change, pollution, and loss of biodiversity. And then I think there is a moment when all of us were really very happy, has been to see for the first time a COP28, a political day for the first time dedicated to health. And this is, it is the beginning, but this is something, that gives you hope that action will not be lagging behind.
Yeah, it was the beginning of an important conversation, and one we'll carry on with in this as well, and which we've been reporting on in Climate Now as well. Helen, was there a particular moment that stood out for you in 2023?
I think for me it was watching the temperature records in the ocean steadily increase to something that just seems absurd when you look back on them, and consequently resulting in the temperatures that we're still seeing in the ocean today. So we were getting phone calls from people in June and July just wanting to know what on earth was going on with the temperature. Broke its record first in the oceans back in March 2023, but it never really went back down again. And then it actually peaked in sort of late August as the highest temperature on record. And it sort of declined again through the boreal winter, which we'd expect, but it just has not got anywhere back to normal average conditions. And so for me, just seeing how that's manifesting through the year and what that will mean for the long-term trends and going into this year is quite outstanding and be interesting to follow.
Yeah, it was literally kind of off the charts, and we'll go and talk about that in depth in this conversation. And Deanna, let me come to you also with that question. Was there a standout moment, climate event, weather event, or political event perhaps from 2023 for you?
For me, perhaps the worst was when the September climate data came out. And already after the summer data came out, we were quite shocked how much we have warmed, how much warmer this summer was than anything before. And I thought, that was the worst that we can see. And then when September came out, and that exceeded even any previous record of readings, that was rather, and even the climate scientist colleagues who work with such data every day, they refer to this as gobsmacking, and literally they were also just holding their breath, what's going on. And whereas we have managed to by and large explain the majority of this, but there are still voices that actually can't fully explain all of that. And I think that's definitely an issue that is still in a lot of the conversations around the climate community.
It's something I wanted to come to you, Sam, about, particularly off the back of this publication, is we have seen all of these records. September, as Deanna says, was exceptional. We had an exceptional year. We've had many exceptional years. But would you say, as a climate scientist, that at the moment, the warming that we're seeing is actually consistent with what was predicted would happen maybe 10 years ago? Did we think about where we are now in 2023, or was in fact the warming going faster or maybe even slower perhaps than was predicted?
So that's a really interesting question, and I think that there's a lot to unpack there. So when we look at the climate, we look at it in the context of the weather events that occur around the world and also the long-term trends. So when we look at the long-term trends, the 3 years prior to 2023, we're in a particular phase of natural variability that has a cooling impact on our climate. It's called La Nina. Whereas in 2023, we transitioned from a La Nina event to an El Nino event, which has a warming effect on our climate. When we look at what the climate models tell us, they actually anticipate that we should be warming faster than what we're observing. So climate models are finally agreeing with what we saw in reality. And one of the reasons behind the differential with the observational predictions of where we'd be in 2023 was because we didn't know that we were going to enter this El Nino phase, which has this warming effect. We also didn't know ahead of time that we would see this record heat in the ocean, and that record heat would be maintained throughout the year and into 2024. However, I still think it's really exceptional that globally 2023 was the first year in which every day exceeded 1 degree above the pre-industrial average, and more than half of days in 2023 exceeded 1.5 degrees above the pre-industrial level. And the pre-industrial level is an average between 1850 and 1900, and it's incredibly important due to the Paris Agreement, which all nations committed to in 2015 to limit global temperatures to 1.5 degrees above that time period, or 2 degrees as a maximum.
But what you're saying is that we're basically a little bit behind where we thought we might be. We thought it might be even more extreme, warmer.
So when we look at climate models, we're looking at a number of different climate models and an ensemble of climate models. And climate models are fantastic at understanding the physics, but they don't react to particular extreme events. They don't have the ability to do so. So when we look at the projections with climate models, there's always an average and an envelope of the above and below that average. So when we look at where we were in 2023, we were within that envelope, but we weren't on the average line. So ultimately, I think it's fair to say that, yes, it was expected that we could be where we are in 2023, but at the beginning of the year, it was considered to be unlikely because of this La Nina phase.
Yeah, Deanna, do you want to comment a bit on that as well? I mean, you're within the heart of the IPCC as well, of course, so you have conversations about these sorts of things, particularly referring to those goals that we were talking about. But what does your community have to say about the general picture for 2023?
I would very much agree with what has been said already. Perhaps it's quite important to clarify, because in the media there has been a lot of discussion, and especially on media, that we have period, and then we can just throw the Paris Agreement away, which is actually not true, because as has been said before, the climate has quite a wide range of natural variability, and even these extremes can actually fit into the natural variability. And if we see the long-term trend, actually they are really quite still fitting into what all of the IPCC reports have been projecting so far. Even it's true that we kind of on the upper edge of this range that we have been projecting. Nevertheless, they are there. And if we look at the long-term trends, because this is what we need to look at, and what we call is the 20-year running average, that is still only at about 1.2 degrees of centigrade. So we have not yet exceeded the Paris target. Nevertheless, I do think that this last year, the extremes and all the different weather phenomena are very important warning signals that it's not good enough just to sit and wait and figure out, are we experiencing some acceleration? Is there anything else going on? Or is this just normal climate change, quote unquote? But we have to accelerate our climate actions.
Absolutely, and we'll get to that. But let's have a look at some of the data then that we got from the Copernicus Climate Change Service. We're going to bring up the first graph, which is very striking and gives us a view of basically the situation of kind of annual average surface air temperature across Europe. Samantha, can you talk us through this a bit? I see a sea of red. It looks like it's just been very hot.
Yes, so this is a map showing how warm it was in 2023 with European country borders. It's using the observational data network EOBS, so it's using data from weather stations around Europe, and it's showing in the warmest red colour, the strongest colour, it was the warmest year on record for those particular countries or regions of countries.
So Ireland, for example, is looking dark red. That means it was the warmest. But then if you look across France or Spain, for example, it's a bit patchy. So some bits of France had their warmest, but some bits had their second warmest or third warmest. Is that how you understand it? And then what happened in Scandinavia?
So Scandinavia was really interesting, actually, and this is one of the reasons why regular climate monitoring is so important, because when we look at the year as a whole for Scandinavia, it looks like it was much cooler than average. But when we look at the monthly maps, we can see that some of the months, particularly when we're in spring and early summer, so looking at January, February, May and June in particular, as well as September, we know that for those months, Scandinavia was much, much warmer than average and had its warmest months for that time period.
Yeah, but then as a whole over the year, then they had a cool time. But that is not necessarily, if you look across where Deanna was just talking about sort of 20-year average, everywhere's warmer across Europe, right?
Yes, that's right. So this shows the difference between natural variability, both within a year and within months and within a region versus the long-term trends. And that's why it's so important to compare both. You know, many people still make the mistake that because it's winter or spring is cooler than it is in summer, but it's supposed to be cooler. That's the seasonal cycle. So we need to extract out the seasonal cycle from these long-term trends. And the long-term trends say that Europe is the fastest warming continent, and it's warming at about twice the rate of the global average.
A lot of people would say to me or ask me, looking at that map, is that El Nino, the traces of El Nino that we can see there that's meant that it was so warm in the last few years?
100% no. And the reason why I can say that so emphatically is because we're looking at Europe. And the teleconnections between Europe and El Nino, which develops in the equatorial Pacific, are quite complicated. The El Nino event only developed in the middle of last year, and we were seeing record temperatures globally from about June onwards. But it wasn't until when we were in autumn, so August, September, that we started to see the teleconnections between what was happening in the equatorial Pacific basin and the ocean and the atmosphere, and then seeing those teleconnections beyond the equatorial Pacific. So we know that there is a global footprint of El Nino on global air temperature maximums and the records that we saw in 2023, but we don't know that for Europe. And also, this has been a very short-lived El Nino event. So it already peaked in December, January, and now we're in the declining phase. And it's in the second year of the El Nino event that you normally get this much stronger influence on global temperatures and stronger teleconnections.
So if it was going to be warmer, or it would be, in fact, now that those impacts from El Nino would be felt. Okay, that's interesting, because I think a lot of people are curious about these things. Let's talk about then one of the key topics which we here Euronews are reporting on at the moment, which is heat and health. That's the latest report I just made for Climate Now in Greece is all about this, particularly in occupational health. It's a concern. It should be a concern for everybody. And when we've reported about it in the past, I think a lot of people associated heat wave and health issues with vulnerable populations, people who are homeless, the elderly, people with existing health conditions that made them more vulnerable. But in fact, everybody should be concerned, is what the message I'm getting from the scientific community. Francesca, you're an expert in this. Just tell us a little bit about the understanding that we have at the moment about that interaction between extreme heat and health. And we'll bring up one of the graphics which gives us an idea of the picture in Europe, which was pretty bad.
Yes. Well, heat and health, they are very closely related, because the temperatures to which we are exposed, they challenge the physiology of the human body. Our body is designed by nature and through evolution to sustain and to be active and to live around 36, between 36 and 37 degrees. And we are very sensitive to that, because, we consider above 37, you get a fever. And this depends a lot on our ability to buffer the exposure to outside the temperature. When the human body is exposed to extreme temperatures, we do lose this capacity, this ability. Our buffer capacity gets exceeded. And this is why the heat can be extremely dangerous also for relatively young and good people in good health, like workers, like outdoors workers during the heat season, because even for them, this capacity can be exceeded. Let's not speak about the so-called vulnerable groups, because of course, heat has a very bad effect, for example, on cardiovascular diseases, respiratory diseases. For children and for the elderly, this adaptive capacity is more frail, is more difficult to cope. And this is why, we must act, because every summer we have dozens of thousands of people who are dying. Unfortunately, for the report, we couldn't provide the data for 2023 because the way you monitor deaths and you attribute them to causes is different from the way, in real near time that you monitor the weather. But, 2022, that was another super record year. We counted 62,000 deaths in just 35 countries. So imagine, every year we are, losing thousands and thousands, dozens of thousands of lives to climate and to the heat waves.
When we look at this chart that's next to you, sorry to cut you off, we can basically see the number of very strong heat stress days. Basically, the number of days, very strong heat stress is when you have a feels like temperature of about 46 degrees Celsius. Is that right? Which sounds horribly hot. Is that a growing phenomenon across this bit of southern Europe that we can see here?
Well, there have been, like last year and for 2 years in a row, I think that Sicily was reporting, temperatures that were never seen, even in countries that are used to heat. And this is something that can challenge health systems and can challenge our capacity to cope with the phenomenon. This is why it is so important for our health systems to be able to be prepared, because what happens is that a heat wave can crash your hospital simply because you may see a very concentrated influx of patients that require immediate care, and this can again interfere with the smooth running of healthcare operations.
What do you do with a patient who's got too hot, Dan? Somebody who's working outside, or an elderly person who's just ended up getting too hot and dehydrated maybe? What do they do in the hospitals with those people? How can they help them?
Well, they very often people with the heat stress, with which is a very threatening condition, have to report to ER emergency rooms. And one of the first things that you have to do is to try to lower their temperature, to keep them hydrated and to try to stabilize them, taking them into a physiological area that is more compatible with human survival conditions. And then you can imagine that when people report to hospitals under these conditions, or with the heart attacks or acute respiratory episodes that are related to that, they can really put your response into crisis. This is why at the WHO...
Sorry, I was going to say, you talked about in the beginning about the fact that you put the WHO Europe came out with this particular announcement about a public health emergency, you described it as, in July last year. Does that have an effect? Does that kind of unlock something within health systems, or is it just raise an alarm and that's all? Sort of what happens when you do that afterwards?
Yes, it does. We are also in a few weeks about to restart our campaign, and it does in two areas. The first one is about increasing public health awareness. We run a campaign which is called the Keep Cool campaign, available in 18 languages. And this one deals with the entail of the phenomenon. It helps people to keep safe from the heat, with the simple messages. But that one, in a way, is like placing the responsibility on individuals, while, of course, as a public health agency, we have to make sure that we as a society are dealing with that. And this is why we are also working to support the member states to develop solid plans for the prevention of heat health action plans. And they bring together emergency services, Yeah, please go ahead.
I'm sorry. I was going to say, I know that in Greece, for example, they take this very seriously. They have kind of cool areas, public areas that people can go to in order to cool down. They're trying to green the city of Athens, which can have a local impact in temperatures, trying to raise awareness as well. I also know that the Greek Weather Service, Greek Met Service, has introduced a capacity to consult the wet bulb global temperature, which is a kind of a complicated thing to try and understand. Try looking it up and try and understand it yourself. There are plenty of explainers online if you're curious, but this WBGT is now being quoted by the Greek Met Service, which is a kind of like a feels like number, right? Do you think that's a useful way forward, in fact, in the evolution of the conversation about heat and health, to be able to start talking about a different thing other than just the pure temperature, but also the feels like, which then says, okay, if it feels like 38 or 37, you need to watch out.
Yeah, I think it depends to whom you need to talk. So, for example, these indexes and so on, they are paramount to set up the response from an occupational health point of view. So you have, the capacity to process and understand these numbers. For the lay people, it may be not as relevant. What is important is to know what to do and to be able to do it and to have the infrastructure to do it. So, but it is true, these systems, these heat health action plans, they only work if they are connecting weather systems, meteorological services with emergency services, with the health services and the social services, because let's not forget that many of those who are dying are people that belong to not only vulnerable age groups, but vulnerable social groups. And this is why you need, a large group, a large system of different disciplines and government actors to be effective.
We reported on this in Lazio in Italy, which had a system that was basically an adaptation of one of their COVID systems in order to reach those vulnerable people you were talking about and raising awareness. But one of the things I think that's come out from the report from Copernicus this week as well, and from other reporting I've seen, is that the kind of risk perception is not particularly high. People are aware that heat and health might be an issue. They might need to that they might get too hot. They need to cool down. They need to drink water, etc. But most people think, "I'll be all right." How do you change that, do you think?
Well, this has a lot to do also with where people live. The heat can be take Italy. If you were born in Sicily, you would be pretty used to hot, and then you would try to underestimate the effect of getting into the extremes. If you were a tourist coming from Sweden to the same place, you would probably feel that you are close to boil alive. So what is very
sure
important,
I would.
What is important is that you is to have very good communications, awareness raising, and not to downplay that, and help people to really get informed and understand, particularly what they can do to protect themselves. But the Lazio that you were bringing up is a beautiful example, because they have had a very long tradition of developing these plans at the subnational level. And this is also the other important bit. You need a very coherent system that supports action from the national, regional, and local level.
Absolutely. And it's something everybody can read a lot more about and hear a lot more about going to euronews.com/climate now, where we have further reports on this topic. Let's move on to one of the other big things from 2023, which is it seemed to rain an awful lot. Samantha, did it really rain more than average last year? And if so, why?
Yes, it did rain more than average in Europe in 2023. But when we look at the numbers, it doesn't seem like it is very much. So Europe was around 7% wetter than average, with most with most of Europe experiencing wetter than average conditions. And depending on the data set used, it was the wettest year since 1981. So the wettest year for about 40 years. As a result,
I think we're going to bring up one of the graphs. Here we go, Sam. Here's one of the graphs that shows in blue. So everywhere in blue, was wetter.
Is wetter than average. Yes, that's right.
Why?
So you can see that large parts of Europe are not only just pale blue, but dark blue, which shows that it's much wetter than average. However, just having a wet year in isolation doesn't mean very much. And this is why it's important to not just look at how much it rained, but how and when it rained, because we have areas of blue in that map in particular that still have a soil moisture deficit, which means that there's agricultural stress and there's impacts on the natural environment from lack of water availability in the soil column. So when we look at 2023, we know that it was slightly wetter than average year, but it was how the rain fell. So because we have a warmer atmosphere with climate change, the atmosphere can hold more moisture. And this means when we have rainfall events or storm events, they drop more rain more intensely than they have done historically in the past. And that's what we also see in 2023, that there are a huge number of flooding events, and that led to impacts on the European river network, which saw about a third of European rivers showing high flood thresholds throughout the year, and 16% exceeding the severe flood threshold. And by severe flood threshold, that means that the rivers are higher than what they have been for a 20-year return period, effectively.
We're going to try and bring up the graphic on that, which shows that. But is it one of those situations where we can say the fingerprints of climate change are all over this? You said, yes, it's warmer, so we have more moisture in the atmosphere. That's the mechanism, is it, that's led us to a situation where it was wetter last year?
It's a combination. So unlike temperature, there's no really strong trends in global precipitation or in European precipitation. It's a data set that's highly variable. And that's why it's so important that it's not just looking at the annual average of rainfall and comparing that with previous years, but really looking at how and when the rain falls. And when we look at the changes of flooding, we can see both from the IPCC data and from the trends in the scientific evidence that there's 3 different trends that we've observed. So firstly, a change in climate both increases and decreases European river flows, depending on where you are within Europe. Secondly, a change in climate shifts the timing of European floods. And we saw that last year. There was a severe flood in Norway and Sweden associated with Storm Hans. And that was the first reported incident of a flooding event in August, in peak summer. And thirdly, the spatial scale of floods is growing across Europe. So this means that local floods just located on one river basin are becoming less common, and flooding across multiple river basins and multiple countries is becoming more common.
Deanna, can I come to you and just, is this something we are seeing in other parts of the world too? The European atmosphere is not isolated from the atmosphere of the rest of the planet. Do we see these changes in rainfall patterns elsewhere around the globe as well?
We definitely do. And in fact, it's more likely that the majority of the impacts related to climate change are actually related to water availability rather than just simply temperature increase. We have talked a lot about heat, and it is true that Europe is the only continent where heat has been taking the largest human fatality toll from as a result of climate change among all continents. The other continents see more impacts from either storms or drought or actually fires. But definitely the availability of water, too much or too little, has been very much impacting other continents. We know several areas experienced severe droughts. We actually also experienced 2 years ago a severe drought in Europe, but and also flooding, which we also did experience in Europe. But other regions are even more vulnerable to this. And in particular, we see that Asia is perhaps the most vulnerable right now to water-related impacts. For example, we saw last week the floods in Dubai.
We do have people, though, who say to us, well, this is kind of just weather. For example, we reported from Portugal on a drought there a couple of years ago. But now I know, having talked to a Portuguese water expert a couple of weeks ago, that the reservoirs are all full again and everything's looking okay, particularly in the north of the country, that at the end of the day, this is sort of just variability rather than anything else?
Well, part of it is, and it is true that we cannot say for every single drought, however severe it is, and every single flood, that it is a result of climate change. However, the science of so-called attribution has really been advancing, which means we can tell better and better whether that particular event would have happened in the absence of human-caused climate change, and how much more probable it is for that particular event to happen with the existence of human-caused climate change. And we see that some events, for example, if the viewers remember the extreme heat event in Canada and northwestern United States in 2021, those, for example, we proved that they virtually could not have happened in absence of human-caused climate change. So now we are much better able to distinguish climate-related events and more just natural variability.
And let's move on then, thinking of natural variability, because I think there's a very clear point there related to rainfall. But what's happening in the oceans is just off the scale crazy. Helen, you've been very quiet until now, but now's your time. Tell us about what's been happening in the oceans, off the coast of the UK, Ireland, France, Spain, Portugal, etc., in the Atlantic. It's been pretty mad, hasn't it?
It's been pretty crazy this year. I mean, globally, as we've heard, we've had the warmest sea surface temperatures on record. But if we focus in on the North Atlantic and around the European regional seas, you can see those on this chart that you can see now. That bright red, dark red colour, I should say, is the warmest on record in the 44-year record that this data set is showing. So you can see quite clearly there the southern North Atlantic sector there of Portugal, of France, the Bay of Biscay region is dark red, and off the north coast of Scotland and Northern Ireland, again you've got these sort of extreme warm years as well. And we're finding that on average these conditions are just sort of breaking records in many areas, but it's a regional variability, and like we've heard in terms of the weather system, the ocean has its own weather, if you like, and ocean currents, wind-driven currents, very different circulation patterns that happen, and that results in these regional variability that we see. So, for example, the heat wave that we experienced off the UK coast last June, so around about mid-June, we saw peak temperatures where it was classed as a marine heat wave category 5, which is 4 or 5 degrees warmer than the average conditions for that month. That was a culmination of factors that actually resulted in that. So obviously you've got the year-on-year warming trends that we've seen, so the surface temperatures in the ocean are warming from climate change. But actually it was a sort of perfect storm of events, if you like, because we also have seen changes in the jet stream, and those have implications for how ocean is circulated. But also there was a pressure system that normally sits off the around the Azores in the sort of North Atlantic, called the Azores high pressure, and it's a semi-permanent system that actually drives a lot of the wind in that region. And at that time of year, in June last year, the Azores high was the weakest it's ever been recorded. And that has consequences for driving wind. And so we actually saw a 20 to 30% reduction in wind at that time. And if you have less wind, then you actually have less circulation of the oceans, and that prevents mixing with cold waters. So the surface water, if you imagine it's like a stagnant pool in that case, that actually you're just absorbing all that heat as it comes in, as opposed to having a nice flowing system where you're actually able to mix cooler water with the rest of the ocean. And so it was almost this perfect storm last summer of having these different factors come together to allow these marine heat waves to occur.
I'm going to ask you the obvious question, I guess, which is this something we can attribute to climate change?
Yeah, I think what we're seeing, it's a little bit early to attribute the 2023 peak warming to climate change exactly. As we heard, we're working on these attribution studies, and they're getting much better. And I'm sure in the coming months we'll probably have something more concrete that actually says exactly what the probabilities of that happening with or without man-made climate change. But I think that without a doubt, the trend of surface temperature warming is going up. And we have these kind of, on top of that, then you have these weather variability, if you like, the annual variability, the monthly variability. And we're seeing increases in heat waves. I think there's been a 50% increase in heat waves over the past 40 years. And so we are expecting to see those as a result of changes in the climate and changes in the way that the ocean circulates water and transports heat from different parts of the ocean have quite significant consequences for how the ocean captures that heat and drives the different heat patterns that we see.
I mean, the ocean does us a favour a lot of the time, right? Sucking up a lot of our CO2 and sucking up a lot of our heat. Is this the ocean giving back some of its heat, or is it more what you were talking about related to the atmosphere circulation, basically the weather being different and more solar radiation being absorbed because of that? Or is the heat coming from further down and being released because the ocean's had enough of warming up?
So it's quite complicated, and there's a bit of everything, and they're very interconnected. So it does get difficult to kind of really say whether it's one thing or another. But what we know is that the ocean heat content is increasing. So the ocean's absorbed about 90% of the excess heat that has been created from global warming, from human emissions of carbon dioxide and greenhouse gases. And so it is doing us a favour. The temperature in the Europe would probably be quite significantly warmer if we didn't have the ocean taking up that heat. And as you say, it works in our favour for other things. It takes up about 25% of the carbon dioxide we emit as well. But in the Atlantic, what we see is that it transports heat and salty water up from the subtropical regions through what kind of most people know as the Gulf Stream up to the European system, the European regional seas, and above into the higher latitude regions. And it's that transport of heat that is going on. But actually, there's some discussion at the moment whether that transport system is actually slowing down. And that's become evident if you look at some of the maps for global ocean heat content and also of the sea surface temperature, where we've got what we call a cold blob in the North Atlantic, sort of just below Greenland. And it's not maybe evident in the 2023 figures because that's just showing where the 2023 weather was warmest or not. But if you look at how the ocean temperatures have changed year on year, we generally see that the majority of the ocean is warmed, but we have a cooling spot in the North Atlantic. And that's concerning because that's related to exactly where this transport of heat system would normally sort of dump its heat, if you like, into that region, the Atlantic. And so
and that could be a climate change effect.
Exactly that. So we're seeing a slowing down of that circulation pattern, and that's a climate-driven effect, and that's due to inputs of fresh water system because we've got more melt and more river runoff, more rainfall in the higher latitudes, which is actually freshening the system, and that again has a consequence for the circulation pattern, which is very complex. So there's different drivers, but they're all very, very interconnected, and they will result in the changes that we're seeing.
Let me bring in Samantha a bit on this. It is super complicated, but you also had a graph on your report from Copernicus, Samantha, which was indicating temperatures at different depths and things as well. Can you give us a bit of a picture from Copernicus about what you understand about what's happening in the oceans at the moment?
Yes, that's right. So when we look at the measurements within the ocean, we're still incredibly limited, unfortunately, by the number of observations. So the ocean records aren't as long as we would like them to be. We've got very good long-term records of the surface of the ocean, but when we go deeper into the ocean, we only have measurements for the top 2,000 meters of the ocean. Everything below 2,000 meters is modeled data. And the types of measurements that are taken within the top 2,000 meters are from what's called a Argo float system. So they're effectively underwater drones. They go along the ocean currents, bounce back up to the surface every now and again, and emit their data back to satellites. We have some in situ observations as well. And what we can see from this data is that the ocean is warming in the top 2,000 meters, and the warmest part of the ocean, the most rapidly warming part of the ocean, is the top 300 meters, followed by the top 700 meters, and then the space between 700 meters to 2,000 meters is still warming, but at a slightly slower rate. So as Helen mentioned, as we get more warming in the surface of the ocean, that gradually mixes through depth, through ocean currents, and through the natural dynamics of the ocean. Again, as Helen was mentioning...
Sorry, I was going to ask you to speculate wildly on what we could imagine would happen in the future then, if that's happening, because it is a complicated picture. As you say, we're kind of lacking data as well, but what would we expect would happen in 2024?
So in 2024, we're already 4 months of the way into 2024. And at the moment, we're just monitoring surface data on a daily basis. And Helen, I think, mentioned that in 2023, we saw the global extrapolar ocean. So when we look at ocean sea surface temperatures, we're looking between 60 north and 60 south to remove the sea ice regions to make sure that doesn't impact the annual trends. And when we look at 2023 as a year, we saw the ocean at above 21 degrees for the first time for about a week in August in 2023. However, when we look to 2024's data, we actually see that the ocean has been above 21 degrees since the end of January. So for the last 100 days or so, 110 days, the ocean has been above 21 degrees, and that is warmer than we have ever observed before this 1 week in August last year. We also know there are a lot of teleconnections with the atmosphere, so warmer ocean. As you can imagine right now, the ocean in the North Atlantic and in the European regional seas is above 21 degrees as an average, but this warmer ocean means that it evaporates more, and it also provides more energy into the atmosphere. So a warmer ocean leads to a warmer atmosphere above it. It leads to more evaporation, which then leads to more cloud formation and more potential energy for storms. So last year, for example, we had record temperatures across large parts of the North Atlantic, and I think we saw the fourth most energy intensive hurricane season for the North Atlantic. So there's a direct correlation between ocean temperatures and hurricanes, which then have those major impacts on, financial losses and impacts on society.
It is an amazing picture that we can get by looking at the data that you've got. And I'm interested, Diana, from your conversations that you have within the IPCC, but also in your other contacts as well with other climate scientists. What is everybody thinking at the moment, particularly when they look at that ocean heat situation, what Sam's just talking about, the heat going back into the atmosphere, all of those feedback loops, etc. What's the general sentiment?
Well, there is definitely a lot of debate in the scientific community, whether it's a range or whether there is something going on, whether we can fully explain what's been happening last year, or whether we are still missing part of the picture. What is clear for everyone, that there were a couple of things that contributed to these extremes that so far we haven't mentioned yet in this conversation. And that's a side effect of something that otherwise we want very much, which is the cleaning up of air pollution. And because we have regulated now, for example, the extremely dirty fuel burning of vessels over the North Atlantic, that actually seems to have probably a very strong warming effect, in a sense that that air pollution has induced some cloud formation, and that has been reflecting some of the solar radiation and has kind of protected us from some level of warming that now we have taken away, that kind of shield, and that now has accelerated the local warming of the ocean. But in general, the latest papers show, even just a few days and a few weeks ago, that it's likely that we may have been underestimating the impact of air pollution in terms of protecting us from some level of the already man-made global warming. So that's one of the issues, but does not mean that we shouldn't clean up the air and we shouldn't reduce air pollution, because it does so far cause more deaths than. But we have to tackle the two together. And there were other things going on also with the Tonga volcano effect, which only volcanoes also cool the weather or climate actually. Nevertheless, this particular volcano erupted in a way that has resulted in more water vapor, moisture emissions, and that actually has been having a slightly warming impact. The bottom line is that we don't know, but we really need to be cautious, and we are getting very close to that miracle 1.5 degree limit, and we just want to make stronger steps towards stopping emissions growing.
Absolutely, and let's move on to solutions. We've got 10 minutes or so left to talk about that, and Copernicus gives us a view every year as well of potential on for solar, for wind, for hydropower, etc. And we know that those are some of the ways that we can try and reduce our emissions is by changing our energy systems. Samantha, can you just tell us a little bit about that and how that looked in 2023? We'll bring up the graphic that you had, which shows the situation for 2023 with the potential. We've seen huge growth in renewables, of course, across Europe. But is there enough sun? Is there enough wind?
Yes to both. And I think that's the really important framing when we start talking about solutions, is that we have the technology right now. And some of this technology we've had for a very long time. So we're not reliant on new hypothetical technologies. It's just the political ambition to transition to a more sustainable energy pathway. So when we look at 2023, we can see that the year as a whole saw a record proportion of electricity generation by renewables in Europe at 43%. And this was the second year in a row where renewable energy production was greater than energy production from fossil fuel derived energy sources. So this is great news to show that the transition is happening in Europe. And but obviously it relies on the political processes and on processes associated with the permitting and building of new versions of solar, wind, and also hydropower facilities to ensure we can drive that electricity demand. And when we look at the impact of climate, so obviously our energy use is driven by ambient temperatures. So in summer, when it's hotter than average, we use more energy to cool houses down. And in winter, it's the inverse, that when we have very mild winters, we use less energy because there's less of a differentiation between the outside temperatures versus the temperatures that we like to keep our houses. And we can see that in the data that the winter was very mild, particularly going into 22-23. So there was lower average energy use or energy demand in winter for most European countries. And in summer, it was the opposite, particularly for the southern European countries along the coast of the Mediterranean, where it was warmer than average, and therefore we required that additional demand for cooling.
It does, though, when you look at that graphic, you see quite a lot of variability. Obviously, we need to adapt to that. Deanna, let me bring you in on this, because I know that you're very good on energy in general. I remember having long conversations with you about this when we were in Sharm el Sheikh, but we do need to adapt to this variability. Are we managing to do that? Because we know sort of how to do it, but are we adapting, actually?
I think that's a really important point because as we move more and more towards relying more on renewable forms of energy, it is important to understand they are weather dependent. So it's a bit risky to rely on one or even two forms of them. So actually, even in these maps, what is a little bit clear, although that's not a rule, but that in places where there was a bit less wind, it experienced perhaps a bit more sun, vice versa. So in the end, if you have a portfolio of different renewable forms of energy, then it's more secure that you will have one of the forms that compensate for perhaps the shortage of the other. So that's one point. The second point, we also need to work together with actually reducing demand and not only think about how we produce the next kilowatt hour of energy, clean energy, because it is much easier to supply all of our energy demand with clean forms of energy if we have lower levels of demand. And by this, I mean that we should, sit in overheated buildings or in winter, actually to cold buildings, dark buildings, but rather that we have to work on how to provide the same or even better thermal comfort at lower levels of energy. And this is where I would also actually come back to the heat stress that we have been talking about a lot, because I feel that we focused a lot on kind of the end of the reaction chain, the healthcare response. Nevertheless, I would say that let's hope that this would be just the last resort. And in fact, we should work on trying to eliminate the exposure of people in Europe to such extreme heat. And one of the ways we can do that, and that there is where we are a little bit fortunate, in the sense that 70% of Europe, over 70% of European population lives in cities. And in cities, actually, the heat stress that we are experiencing is more, right now, still more related to urban heat islands rather than to man-made climate change. It's also important, but human-caused urban heat islands are neighborhoods much more than climate change. So it means that if we work on reducing or mitigating fully urban heat islands, then actually we can, for a while, mostly compensate for human-caused climate change. So we could actually still manage the heat-related stress. How we do that? Already mentioned what happens in Greece, more and more urban trees, and urban trees are a fantastic synergy between adaptation and mitigation, because not only do they provide shade and actually air condition our cities, so keep them cool, but they also actually sequester a lot of carbon. So globally, currently urban trees sequester over 7 gigatons of carbon, and every year they sequester an additional 400 million tons. So that's quite a substantial amount. Also, if we reduce the need for cooling by good buildings so that the houses don't get overheated, learning from vernacular architecture, with good shading and more green and blue infrastructure, meaning more trees and perhaps ponds in cities, less concrete and less sealed surfaces, that also people as well as buildings cooler, and we reduce the need for cooling energy. And that way, going back to your original question, we can use better that available amount of renewable energy.
Absolutely. That sounds like a fascinating future, though. I mean, bringing things back to the reality, though, as I like to do, because I have read the report, greenhouse gas concentrations are still rising. We're at 419 parts per million of CO2 in the atmosphere. It's increasing about 2.4 parts per million per year. For those who want to have a comparison, it was at 327 parts per million back in 1972 when I was born. Sea levels, which we haven't mentioned, are continuing to rise. They've risen 10 centimeters since I was at university in 1993. We continue to see economic losses because of the situation that we have with climate change. Samantha, we are still talking about making a difference. We understand our climate well and better, thanks to your reports, but we don't necessarily see big changes going on in the atmosphere, leveling off. Do you think there's any chance that that might happen in 2024. There's some speculation maybe 2024 we're going to get to peak emissions and it'll start to go down. What do you think?
I think Diana's probably better placed to answer that than I am, but the reality is we have to remain optimistic. The second reality is that every single fraction of a degree matters. So even if we overshoot 1.5 degrees of global warming temporarily, then it's important to make sure it's as short a departure above 1.5 as possible. We know there are tipping points in the climate system. The science is evolving all the time on understanding the thresholds associated with when those tipping points kick in. And the North Atlantic circulation is one of those tipping points that's particularly critical for Europe. So I am hopeful that through the extreme events that we saw in 2023, including the largest wildfire that Europe has ever seen, more glacier melting than Europe has ever seen, more flooding. And in terms of the numbers of flooding, the losses from climate-related events last year are estimated at over 13 billion. And about 80% of that 13 billion is associated with flooding. So hopefully the financial calculations and the scientific evidence is overwhelming to transition to that ambitious, rapid change that we so desperately need to get to net zero as quickly as possible and to adapt our cities to the current climate that we're facing now.
Absolutely, and how that will change in the future as well. Final thoughts, maybe. Let's come to Helen for your final thoughts on this. You're an oceanographer, but you're sitting there listening to all of this and thinking, crikey, this is all of us, isn't it? What are your thoughts when you look at this data and you hear about it?
Absolutely. So I'm an oceanographer, but I'm also a human being and a citizen and a mum. I've got 2 young children. And I said probably 15 years ago, so before I had children, that I work a lot in the polar regions in the Arctic, and I said I would love for them to be able to learn about sea ice as a geography lesson and science lessons, and not history lessons. And I fear that if we don't act soon, then we are actually going down that route of learning about these things as in our paleo oceanography lessons as opposed to current oceanography lessons. And I think even though we've heard today that actually there's not necessarily long-term data sets in the oceans, I mean, we do have good records going back 40 years, but it's relatively sparse in terms of where we've got those records. We know enough about the system. We know enough that things are changing to be acting. I would argue that it's very difficult now that we're actually experiencing a lot of these extreme events and we're starting to live out some of the predictions that we made 30, 40 years ago that have only really got better at being able to say this is where we are and we are now there. That I think we have that information. We need to be acting on that information and making change happen.
I think we probably are acting on it to an extent, but just not going anywhere near fast enough. That seems to be what I get from an awful lot of people. Francesca, can I just get your final thoughts, please?
Yes. I think what is very interesting is to see that more and more people are coming to converge around the so-called co-benefits of action. Diana, you were mentioning the greening cities, making them greener, bluer, and so on. And the mistake I think we are still making is that it is seen as a kind of not yet seen as an investment, but as a cost. And what we are missing there when we make the cost-benefit analysis is to factor in the whatever else you gain by making those transitions. And I think that turning a city into a place which is cleaner, I can understand that there is a scientific debate about air pollution, but let's not forget air pollution kills 7.5 million people per year killed by air pollution. And this is enormous. And how many of the policies that we are advocating to reduce air pollution are also the same policies that we advocate to reduce climate change? So on which platforms are we selling this advocacy? So Perhaps we have to change the discourse and to say what I tell people when I promote active mobility, active cycling and walking together with the public transport. I don't care really why they do that, as long as they do it. And if the reason to do that is to make us a more livable, a healthier city where people want to live, want to work, want to see their children growing up, let's do it. Because otherwise we will keep, keeping into this thing which is very negative from a political action point of view, of seeing things as a sufferance, because now we have to act on climate change, we must be cold, we must be, we must change, have a miserable life. No, it's beautiful, can be beautiful and can be happy and can give prosperity to your city. So perhaps we have to work more with the communication people to change the discourse and to make these strong policies that are needed, like mainstreamed, embraced by us as a society and by policymakers.
What a lovely positive message, and I think probably I'll end it there. Then it's been a fascinating conversation. We've gone a bit over time, but it was really great talking to you. And everybody who's interested in learning more about climate change, have a look at the Copernicus Climate Change Service's website at the moment, where you can download that report, find out what happened in Europe. I also suggest that you have a look at pulse.climate.copernicus.eu, which actually gives you information nearly in real time about the situation related to climate change where you live. So you can see that a couple of days ago it was definitely cooler than average where I live and in other parts of Europe as well. It's an utterly fascinating website, so please go and have a look at that. So thanks very much for joining us. I'm Samantha Burgess, Deputy Director of the Copernicus Climate Change Service. Great to have you on the show. And thank you to Francesca Racioppi, the head of the WHO European Centre for Environment and Health, to Diana Ürge-Vorsatz, the professor at Central European University and IPCC Vice Chair, and Helen Findlay, biological oceanographer at Plymouth Marine Laboratory. Thanks very much for being with us. Please head over to euronews.com/climate now to find out more about how our planet is changing, and follow Euronews wherever you get your news to find out how the world is changing and keep up to speed with the latest information here from Europe. See you soon.